All right, well, welcome everybody to the latest OutBack webinar. This week we've got a special guest, so I'd like to introduce Jason Trager from Sustainabilist, and I've invited him to come and talk to us about basically, how we do a better job of the actual installation of systems. And so, he gave a pretty well-received talk at the NABCEP conference back in February, and wanted to get some of that for all of you. All right, without further ado, let me hand it over to Jason.
Hey, hey everybody. My name's Jason Trager. I am the managing partner and lead data scientist and founder at Sustainabilist, and I am dead set on using statistics to help improve solar quality of installation, as well as using Toyota style process improvement methodologies. So for this talk, if you could paste this the link that I pasted into the chat, there's a series of worksheets that we've developed that everyone can really use as takeaways. Paul, you want to let me know when those make it out to the fine folks attending.
Looks like you just sent it to me, so let me take care of that for you.
Yeah, that would be great. Thank you. And my focus today is going to be on less so on any specific piece of a solar installation, although I will use examples from solar, and more on how do we actually look at problems in a way that allows us to improve them in a manufacturing style method while out on the solar field. And so I'm going to talk quickly through a brief history of quality. So it's just kind of a little history. And so we're going to start in the 1920s. And with a man named Walter Shewhart. And Walter Shewhart was the father of statistical quality control. And many of you might know about a process called Plan, Do, Check, Act. And that's commonly known as the Shewhart cycle or the Deming cycle, after his protege Deming, that we will get to later. He was the inventor of control charts and defined quality improvement as a process to diagnose and remove process faults through the scrutiny of process variation. And the way this relates to solar is in enabling us to eliminate those process problems where you find yourself rolling a truck again and again and again over the same issue and can't seem to correct that in your processes. In 1927, a man named W. Edwards Deming met Walter Shewhart while working at the USDA. And in 1942, Deming was suggested a course in Shewhart's method to the Secretary of War. After the war, after World War II, there's a famous story where Deming went and spoke to Ford and Chrysler and GM and was sent to talk to them and tell them they can use the process improvement to improve their cars. And they left him out of the room, and then he went and talked to Toyota, who then proceeded to eat up those points. And so Toyota adopted Deming's 14 points of total quality management and just launched from there. In 1955, Shewhart and a gentleman named Taguchi began to work on statistical methods to represent loss functions or ways to quantify deviance from compliance. And then in 1960, which was only a few years after Deming got to Japan, Taguchi won a Deming Prize for individuals to just show how much the Japanese management philosophies adopted and internalized this Deming process. So then in 1980, Six Sigma, which you might be familiar with or hate, depending on your leanings, was established at Motorola. In 1981, the American auto industry started to seek help from Deming starting with Ford, and 5 years later, they became the most profitable US automaker. In the 90s, Six Sigma continued to propagate. In 1993, W. Edwards Deming passes away, and in a notable quote says, "I probably won't be remembered, well, maybe as someone who kept America from committing suicide." I particularly enjoy that quote. In 99, Ford adopts Six Sigma. And then just to tie this to solar now, in 2002, NABCEP is officially incorporated. And over the early 2000s, a series of industries begins to really work to utilize quality. Toyota recovered from the Great Recession quickly. And in 2008, NREL, the National Renewable Energy Laboratory Reliability and Systems Engineering Group, begins looking at solar quality, which has been a real focus over the past 10 years. In 2010, Japan and NREL established a partnership to look at this solar quality task force called PV-QAT, QAT. And in 2014, a European standard was formed, IECRE, to implement a global certification system for high quality standards in solar. During this time, I finished a dissertation looking at how to apply quality to energy efficiency in buildings. And then in 2016, I tripped and fell into solar and said, hey, this is a manufacturing problem. How can we help look at this from a manufacturing lens? And so with that brief lightning round history, I want to bring to bear the core reason why I think we should care about this is because given all that history of quality, we can look at the automotive industry as an example, and we can say, okay, Toyota makes 3 to 4 times more per car than any other of the big automakers, Ford or Chrysler or GM, and their cars last 100,000 miles longer, all because of their focus on quality. In solar, in residential, where my firm manages the data science behind the majority of US third-party residential quality assurance for our clients, 30 to 50% of solar energy installations are quality deficient. And so there's a lot of talk, people say, hey, we can't spend time to improve things, it'll cost extra money. But we have these historical examples where actually improving the quality can increase the profits of the firms and make the systems last longer at the same time. And it's a goal of ours to help our customers achieve that. And so just to go through the 14 principles of total quality management quickly. Principle 1, base your management decisions on long-term philosophy, even at the expense of short-term financial goals. 2, create continuous process flow to bring problems to the surface. This is a just-in-time philosophy. What this means is that when you are doing a job, if you take one step at a time and finish one piece and then do the next piece and then do the next piece, problems with the process will surface and be more diagnosable than if you prep the panels and install the racking and are doing all of the pieces all at once. And so it is useful to do things in a continuous flow, to find the problems, diagnose them, and prevent them in the future, which is at the core of quality. Use pull systems to avoid overproduction. So don't sell more than demand. Level out workload, eliminate waiting. So look at scheduling and say, how can we schedule more evenly? Build a culture of stopping to fix problems to get quality right. Eliminate rework. Standardized tasks are the foundation for continuous improvement and employee empowerment. So how can we adjust our processes to be more standardized? Use visual controls so no problems are hidden. On a construction site, this can be as simple as training employees to raise their hand and wave down a supervisor when there's a problem that they can't solve themselves or that they need a second opinion on. Principle 8, use only reliable and thoroughly tested technology that serves your peoples and processes. Grow leaders who thoroughly understand the work, live the philosophy, and teach it to others. Principle 10, develop exceptional people who follow your company's philosophy. Principle 11, respect the extended network of partner and suppliers by challenging them and helping them improve. Really, really, really important to give feedback. And the folks at OutBack have been really interested in this and hearing from folks about how to improve products, and that's been an area where I've really enjoyed talking to them about. 12, go and see for yourself to thoroughly understand the situation. You can't solve a problem unless you get out onto the site and go look at it. Make decisions slowly and by consensus, thoroughly considering all options, and then implement rapidly. It's much easier to make a good decision if you take an additional few minutes just to think about it. And principle 14, become a learning organization through relentless reflection and continuous improvement. And so I'm going to ask everyone here to just commit to using data to solve problems. And this is referred to as blameless culture, where we can assume people are doing the best they can with the information they have. We can create an environment where people can explain why the action made sense. We can see human error as an effect of deeper systematic vulnerabilities within an organization, and we can dig deeper into problems using the 5 whys technique, which we'll go over shortly. And we want to celebrate organizations that can improve by constantly seeking out their systematic vulnerabilities. I want to see if there's some signal of how if people have opened the worksheets. Let me see. Can I just assume everyone's opened the worksheets and are looking at them? Well, we'll just make that assumption. So if everyone could open up the cost of poor quality worksheet, I would love to just work through this really quickly and have everyone work through it. And so the idea of this is to really quantify how a problem has affected your business over the past year. And the idea behind this is to look at a specific rework problem. Let's say weaves. Let's say that the problem is that that weaves get reinstalled instead of only being used once and then fail, and then you have to go out and fix them. And you want to say, so you want to list the business problem and say, okay, I have to go do a rework on this, and the related error is that weaves are only used once and should be taught to only being used once. A consequence is I have to drive the site back. I have to drive a truck back out to the site. It cost me $300 to do this. I've done this 10 times in the past year. My cost per quality there is $3,000. Another consequence might be that I had to schedule the site, and so I had to receive a phone call, and I took that phone call, and it took $25 for my receptionist to schedule that because the amount of time they had to spend on the phone. And then we want to add up all these single instances, multiply them by the number of times this error has happened in the past year, and we get annual costs. And this is the first step in prioritizing how to improve problems in a total quality management fashion, because it enables us to see what each problem is costing us and to focus on the most costly errors. So I'm going to give everyone just a few seconds to look at that worksheet. Okay. So what I'd like to do is, if everyone has kind of got some problems in their heads and thinking about the cost of poor quality, I want to talk about how we find and prioritize process flaws. Because once we know how much the quality of the processes is costing our business in terms of dollars, then we can start to prioritize them and map them. And so I wish I could see everyone raising their hands, because I usually ask at this point, who likes flowcharts? Because engineers typically like flowcharts. And so our next process tool is process mapping and using what we call swim lane diagrams. And so the swim lane diagram is a tool to help individuals and companies navigate processes in a way that enables them to separate those into functional units. And so we did some work recently with the Amicus Collective, the Amicus O&M Collective, and we looked at their preventative maintenance standardization. And what we would do is divide the swim lanes into office crew. So the technical manager, the project manager, the salesperson who receives the call from a client and develops the scope of work. And then we would make a swim lane for the crew in the field and the people who would be out in the field doing the work, and we would develop a flow chart for them. And we would develop a flow chart for the crew once they get back to the office. And we divide this into 3 sections. And the idea behind process mapping is that if you sit down and draw out your processes, say an installation, using the swim lane diagram worksheet, then you can look at the process and determine how to improve it in a manner that helps to prioritize the errors that you'll find in the process. As you talk through it, you will find these individual pieces of problems. And so for our sample, if you have the diagram in front of you, and you may just want to pull out a piece of paper and sketch it on there if you don't have a printer, you want to label the office staff, the crew in the field, and the crew in office, and help separate where work gets done in the flow chart, and begin to draw a simple process in your organization that involves all these 3 lanes. So just maybe a basic install. On the worksheet, there are lists of shapes that you can use: rhombuses for decisions, rectangles for processes, slightly different rhombuses for data points, and you want to draw directional arrows between each step. And that is a basic swim lane diagram. So somehow you can email the link after the web. Okay, so if you're having trouble getting the link to work, I will gladly send out the message afterwards. So, is there a way we can have, like, oh, there's questions here.
Yeah, so there's 2 ways to do questions. So there's a chat function where you can ask a question, or you can raise your hand. The chat one is a little easier for me to manage, but if you want to do the hand raise and kind of get a microphone, then happy to do that as well.
Yeah, I would love to hear people's thoughts, even if it gets a little chaotic. This is really organized around these worksheets. So, does anyone have any questions?
Yeah, I don't see any hands going up just yet,
Okay,
so
then we can continue.
yeah.
So I'd like to encourage everyone to just make a swim lane diagram of a process. And so this is an example, very simple swim lane diagram, that in the office, we might have a customer call. We go through a diagnostic checklist with the
Okay, hey,
customer.
we do have a question come in. And basically
Yeah.
the question is, would you consider there to be a maximum number of swim lanes?
No, I actually wouldn't. I mean, you're going to get unruly after about 6. And you want to run the trade-off between digestibility and diagnosability, right? So if you have multiple swim lanes, it can help diagnose problems with the communication between parts of your organization, and it really helps build the empathy between your functional groups and a larger organization where you see how the sales interacts with the field crew. So more swim lanes helps with that. But then if you make a large diagram, it can get unruly, and you might want to divide it into sub-processes.
So it's a function of how big is your paper and how big is your brain?
How big is your paper and how big is your brain? Yes. Any other questions on that one?
That's the only one I've seen so far.
Okay. So this is just a simple way to look at it. And when I gave this talk at NABCEP, I really realized how new many of us can be to drawing diagrams of processes. And what we found is that the first time anyone just draws the process of what they're doing, there's a step in there of, hey, how does this work? And when you draw it out, it's almost like the simple machine of process improvement. It's like a lever. You say, hey, is this going to help me lift this huge rock? Like get this process improved, and just using this simple tool will help drill down to a point where you find problems that really focus your attention. And so our simple example here is, say you have a customer call, you go through a basic diagnostic checklist. You say, is it fixed? Did resetting the router bring your monitoring system back online? No? Okay. The field crew gets notified, prepares a work order, rolls to the site and fixes the problem. You check if it's fixed again. If yes, you end. And then the question is, how do I prioritize my issues after fixing them? And I think this, if I could say take one thing away from this webinar, it is try and use Pareto charts. The idea behind a Pareto chart is that it's a method of prioritizing improvements in order of need. The left axis shows how many times a defect occurs. So in our Pareto chart here, we have similar metals for grounding as a problem, flashing installed incorrectly, labeling done incorrectly here. Junction box is secured, panels are secured, wire management, disconnect plainly visible, conduit installed correctly, inverter powered, and ground fault alerts, which should be familiar problems to anyone installing solar, that sometimes we don't get these things right. So oftentimes I feel organizations don't actually quantify which of their problems are the worst, because some problems just feel worse. Some problems feel like they're lighting the place on fire when it only happens once a year, and some problems slip under the radar when they are actually happening every day. And so on the left side of this Pareto chart is the absolute frequency, the number of times a problem occurs. On the right side is the percentage of total problems that problem represents in order. So for instance, for similar metals grounded, it is something like 15% of the problem circled here. But if we were to go in our company and just completely eliminate the first 3 problems, we would solve something like 42% of our issues, which is on the, oh, no, I screwed it up. I was looking at the left axis. We would solve something like 57% of our issues as per the right axis. Even looking at these things all the time, they're hard to read, but they're incredibly useful. And so this is a tool to quickly say, okay, where are our common problems? And what I would recommend is just, you can stick a printed Pareto chart up on the wall of your operations center and just say, this quarter, this is where our problems lie. And if you can slowly improve that, then you will slowly knock out things that have been plaguing you even though you didn't realize them. So we have a Pareto chart worksheet that will walk you through constructing a Pareto chart by hand. And if you open that up, on the front is an example of how to construct a Pareto chart with 3 issues. And on the back is a tool for you to do it yourself. And in our example, the Pareto chart, we're examining problems in invoicing. And we look and say, okay, 3 times an invoice has been printed landscape instead of portrait, which we don't want. 2 times an invoice has had line items that had incorrect subtotals. And once an invoice was lit on fire and thrown out a window. I don't know how that happened, but it is definitely a problem. And what we want to do is prioritize these in order of their occurrence, and then make a plan to deal with them in order. And so how do we go about, after we know what the problems are, doing root cause analysis and improvement planning? I imagine that some of the folks on the line might have kids. And I imagine that they have been asked why 100 times by a child in search of an answer. And I think that this is the most brilliant method of problem solving that has ever existed, because it really gets to the root of things. And so one of my favorite problem root cause analysis techniques is called the 5 whys. And it is a technique that's useful for developing countermeasures. Because oftentimes when you ask why the first time and you say, okay, why did this happen? You come up with the solution. After the first solution, you would say, how do I prevent this from happening again? And that would not actually prevent it from happening again. But if you ask why 5 times, you can get to the root cause of a problem and then say, we are going to implement a countermeasure in order to stop that root cause from happening ever again. So this is a technique that was invented by Sakishi Toyota in the 1930s, and it will take you down for each deeper layer of the issue. So in this example, module's not properly grounded, 690.43d of the NEC. Why'd that happen? The ground clip was not properly secure. Oh, by the way, I really dislike weaves because they pop up in the data as being reused all the time. The clip was deformed, and it was because it was reused on the module installation. This happened because there was an insufficient quantity of clips that were available on the truck. And this happened because only the specified number of clips needed for the install were stocked on the truck, and so there were no spares. And so the countermeasure to this would be to bring spares and to train crews that these can only be used once. And so on the 5 whys worksheet, I'd encourage you just to print it out and take a look at a business problem, such as that there's a lot of rework due to weaves being reused. And continue to ask yourself why until you reach the root cause of the problem. Okay, I'm gonna stop for any little questions here and then move on to the next section, which is how to look at quality assurance and quality control.
So don't have any questions. We do have a couple of comments. Kids invented the process, so that's pretty cute. Or as you said, not using weebs. Presumably using a 2703 listed racking solution or something like that instead would probably make more sense.
Mm-hmm. Yeah, I just have seen a lot of data out in the field that people use single-use weaves more than once, and it fails inspections all the time. So if I were to say a concrete data point, another concrete data point on process improvement is flashing. Like many people don't get it under 2 runs. But that's those are specific points. Any other comments or questions from the audience?
I don't see anything else coming in, but think about this in terms of inverters as well, right? So we've been trying to do this and look at our fundamental products.
Yeah.
But it's like, hey, the inverter is doing X. Well, why is it doing that? Well, because it's in this mode. Well, why is it in that mode? Because I put it in this mode to avoid X, Y, Z other problem. And we actually use this when we, for those that have called in and gotten tech support, we kind of drill down in a very similar fashion, combining this method with a sort of troubleshooting, where you try to isolate each individual problem.
Yeah. What do you think one of the most common problems with the tech support gets asked about is?
There's a couple of them that come up a lot. So things that are miswired is pretty common, especially when you get into the very complicated systems like a GSLC. And then, also there's, the mate 3S menu is relatively big and somewhat complicated. And so, we do run into situations, fairly often where people think a mode does one thing, but it does something else. And so I'm, running product management, I'm trying to find ways to make that more intuitive. So if you look at Skybox, we've taken big steps to solving some of those problems. And now, we're trying to make sure we didn't create different ones at the same time. But
yeah,
it's this kind of process, just iteratively over and over again until we get it right.
Yeah, and so I think that when I look at Skybox, I very clearly see the countermeasures to the problems, of say the wire management. When I look at that, and I'd love to walk through kind of like a 5 whys of when you find some of these problems, but maybe we can get to that at the end if you want. So let's go through like what makes a good QA/QC question, and then we'll take questions, but then we can also kind of walk through some examples specific to the inverters. So again, I'm just going to stress this: quality is the driver of profit, and quality assurance and control is the driver of good quality in the field. 30 to 50% of residential sites require some level of rework. QA/QC improvement can pay off just due to lack of reduced home damage for many many installers. The long tail of installers makes standardization difficult. So standardizing products can really help. And different jurisdictions require different QA/QC grading. On commercial, rework tends to be standard after site possession. Asset management intake surveys occur on Slack and via email. And asset management pricing is not dynamic based on quality assurance. And so financiers have a lot of trouble like pricing this into their methodologies. And so what we want to do is avoid inspecting everything. This is a diagram of how a factory looked in the 1920s. We want to avoid inspecting things, and you'll notice that this is kind of how we do it in solar and in a lot of places, is that we will put something in and we will check it, and then we rework it if there's a problem. And instead, a modern process, no, this is not the 1920s manufacturing cycle, it's the modern one. We observe, we evaluate, and we diagnose a process as we put it in. And so, for instance, if you're installing wires, putting colored tape to match the color of the wire where you need that wire to go can prevent miswiring. Is a solution that many companies that I've spoken to implement, and that makes it easy to look at it like a process. So you don't have to inspect it. You just say, I match the wire to the color on the tape, and it's visual management. So it's a visual management tool that tells you where things go. So I wanted to leave 20 minutes for questions and discussion. Here's some suggested reading. And Paul, if you wanted to talk about some inverter specific examples, now would be a good time to bring any of those up. And if we have any questions from the audience, that would be it would be a good time to talk about those.
Okay, so you guys are welcome to hit the little hand raise button if you have a question or a comment, and I will unmute you individually. That way we don't get a ton of background noise. Yeah, and this is useful stuff. Hopefully people are thinking about, how this is applied, in the construction setting, because all of these tools, when you're on somebody's rooftop building a solar array, you are in a sense manufacturing a PV system. Similarly when you're putting in, the inverters and batteries and so forth. And this is a topic that I thought was important because when you're adding batteries to things, it gets a little bit more complicated, as I think a lot of you will appreciate, and it's really important to get it right. So we've seen in the past, some kind of rookie installers, and sometimes some more experienced ones, will wire the battery in reverse polarity. So that's kind of like if you turn it on with a battery wired in reverse polarity, you're done, and we don't warrant that because you've installed it wrong, and basically everything is going to fry. So what we did with Skybox is we put a little LED light there, so if you have your battery wired in reverse polarity, that LED light comes on, and basically that's an indication that you don't want to turn it on until you fix that. So this little light with a little label. Ideally, I'd love to make it so that didn't cause any problems, but there's really no way to do that short of things that are going to make the inverter cost 3 or 4 times what it already does.
And just to examine that again in the context of visual process management, right? So that's a concrete problem, right? Why does that happen? It's because you label it wrong. Well, what you installed it wrong. Why? Probably because some batteries don't have colored terminals, right? So what I would suggest is just putting a little red electrical tape on the positive terminal before you take your batteries out to the field, like as they come into the office or whatever. Just and have it be part of that process. That there's that extra layer of visual management of which wire goes where. And humans love to follow visual cues. Um, it's what makes this process improvement methodology of visual management so so effective.
Okay, so we've got a question, just kind of a logistical one. Can we share this presentation with coworkers? Yeah, I think that's totally fine, Jason, unless you object.
Yeah.
We are recording this and we'll post it on OutBack's YouTube channel. So you'll see that afterwards. And then if you want to reach out to Jason for other questions and things like that, he's in the consulting business and can help you.
And I'll be at SPI. I'm teaching one of the full day workshops on really in-depth statistical techniques for process improvement. That's for larger installations. And I'm generally just really nerdy about this. So if you want to shoot me a note, I'd gladly just, shoot it over. Are there other questions?
No, I'm not seeing any yet. So we'll give it another couple of minutes, and then if there's no other questions, we'll probably just wrap this up a bit early and give you all back your last 10 or 15 minutes. But while we're here, this is a great opportunity to ask those kind of questions. This is a topic that I think Jason's the first person I've encountered to really address this in a formalized way. And having worked with some of the larger installation companies, they've been heading this direction for a while, and these kinds of approaches, are really the way to save more money on each job, and at the same time to give your customers a much higher quality product that's going to last throughout the warranty period.
Yeah, and it lets you have those more of a formalized record for warranties. In fact, a lot of the manufacturers we've spoken to like that because it's like, this is our process. And then when the warranty claim comes up, you can call OutBack and be like, okay, here's my flow chart of how I did it. Here's the quality assurance log for that job, and it makes everyone's life easier, and it gives Paul more feedback on the product so it can be made better for you, which is another goal of ours.
Yeah, so I mean, generally, guys, if you're installing stuff and you're applying these kind of processes and you're saying, it'd be great if I had XYZ labeling on the inverter, or if the battery was like thus and so, we can't do all of that, but I can't do any of it if I don't know that that's helpful. So you can reach out to us directly. Most of you have, if you don't have my email, you can always send it to sales@outbackpower.com. And that'll get to the right people up to and including myself. And otherwise, reach out at events and ESSP, so on. So pretty good stuff. I don't see any other questions coming up or anybody raising their hands. So I think we'll call it good.
Okay. Well, thank you very much. Feel free to reach out, and big thanks to the folks at OutBack. I think that their commitment to improvement is admirable in this industry and is setting a stellar example.
All right. Thanks, everybody.